All right. So now we've looked at the way that this output nature of the piston can be adjusted so that perhaps a little bit of some rotational motion of the piston would not be a big problem. And we're going to go over here to talk about some other things with these little scenes that I've created. And we're talking about something with this PistonRobot sensory system that consists of a just brand new use of parts. And nobody is using Wi-Fi transceivers broadcasting in closed, tight constraint through ceramic for the purpose of position determination. Nobody is doing that. I don't know why. It's a mystery to me, but they aren't. So one of the things we can talk about is the concept of innovation. And I want to talk a little bit about innovation. And there's two different things that can happen with innovation. And here is a story of innovation. And for some reason, I'm connected to sand. I have no idea why, but let's do sand. So your friend has taken in the junkyard a fully and completely normal and okay metal wheel off of a car. It has a tire on it. The tire's full of compressed air, and your friend says, I just don't want it to have compressed air in it. I want it to have sand. So I'm going to drill a hole in the metal wheel, and I'm going to fill the tire up with sand instead of compressed air. That is innovation. It's new. No one's ever done that before. And there are ways of approaching and reacting to innovation where someone will say, well, you can't do that. And the reason why you can't do that is because you are not doing with this what it was designed for. And since you're not doing with it what it was designed for, it's not possible. And there's a distinction between it's not possible as opposed to it's not feasible, it can't be done inexpensively, it's not safe, it has no appeal to anyone, you're going to regret it, it will make it a bad tire. That's totally different from saying you can't do this. And you don't have permission to say that you can't do something simply because you're using it in a way that others did not design their equipment to be used. The other way that we can approach innovation is a slightly different situation where, again, we'll do sand. And your same friend has said, I've never really enjoyed the flotation vest. I just don't like that foam in there that gives them buoyancy. So I'm going to open them up, take the foam out, and replace it with sand. And I will have a safety flotation vest filled with sand. And you will say, well, sand is denser than water. And so a flotation vest where the flotation chambers have been replaced with sand will sink. It's not going to provide any flotation. And your friend may look at you and say, well, yes, that's how they're designed, but that's not what I want to do with them. And so that's not going to happen. And the answer you can make with respect to innovation is it doesn't make any difference how well your friend has figured out in his head how he wants something to work, because that's the way he wants it to work. The truth is, if it is not supported by physics, if it violates laws of physics, it doesn't make any difference how much he wants it to work. If it doesn't support the laws of physics, if it's not compliant with the laws of physics, it's not going to work. And this is what we've drawn out here to try to show you a demonstration of what we're talking about on the topic of these transceivers.